What we're going to do from now until the rest of the year, we're going to take some sections from chapter 11 and then some sections either from chapter 12 or chapter 10. We're going to get done as much as we can, and then but I do want to give you some more tests so that you have an opportunity to raise your grade before the end of the year. All right. The chapter 11 has to do with sequences and series. Sequences and series. And this first section deals with a lot of vocabulary associated with that. So there's some formulas. All right. So what is a sequence? A sequence is just a series of numbers, or a sequence is a bunch of numbers, all right? And usually they're associated with a pattern, like 1, 4, 7, 10, 13, 16, all right? That's called a sequence. All right, so let's talk about sequences first. Now, in the first example I wrote up here, T sub n. T stands for term. N stands for the number of terms. Okay? So N is the number of terms. N is the number of terms. T stands for term. Okay? Given a formula, T sub n equals negative 2n plus 3. Let's find the first 5 terms of this sequence. So in other words, I want to find T of 1. I want to find the first T sub 2. Remember, T3 means the third term, T4, and T5. We're going to find the first 5 terms. If n is equal to 1, then negative 2 times 1 plus 3, that's the first term. The second term would be negative 2 times 2 plus 3. Third term, negative 2 times 3 plus 3, and so on. Okay, so the first 5 terms of this sequence, well, let's see, negative 2 times 1 is negative 2 plus 3. The first term is 1. The second term, negative 1. Negative 2 times 2 plus 3. Then negative 2 times 3 plus 3. Negative 2 times 4 plus 3. And negative 2 times 5 plus 3. Okay, and that's our sequence. First 5 terms of that sequence. That's easy enough. The formula given here in blue, that formula, there's a name for it. It is called an explicit formula. Given an explicit formula, we could find any term. If I wanted to find the 120th term, real easy. If I wanted to find the 120th term, it would simply be negative 2 times 120 and then plus 3. Okay, which is negative 357, I think. All right. Negative 2 times 120. Oh, that's 240. 237. Okay, so it'd be real easy to do. And that's called an explicit formula. Okay. Let's take a look at the next example I have up there. Find the first 5 terms. Notice I gave you the first term. Okay, so we're going to have to start with 2. So that n is going to have to be greater than or equal to 2. Because I already know what the first term is. It's 6. I've given you that. But that's a little bit different. Because this says 3 times t to the n minus 1, sub n minus 1. What does that mean, do you think? Yeah, the previous term, yes. So what you need for a recursive formula, and this is called a recursive formula, recursive formula. In order to find, T1 is given. In order to find the next term, T2, it equals 3 times t to the 2 minus 1. Well, t to the 2 minus 1, that's t to the first term, and then plus 5. So 3 times 6, because that's your previous term, 18 plus 5, the second term is 23. Here, you need the previous term to find the next one. To find the third term, it is 3 times the previous term, which is 23, and then plus 5, okay, which is 74. The fourth term, 3 times the previous term, which is 74, and add 5. Okay. And then if we want to find the fifth term, 3 times the previous term, which is 227, plus 5, 681, I think, plus 5. 681 plus 5 is 686. So the first 5 terms of this sequence is 6, 23, 74, 227, and 686. That's the sequence. All right? So, can you find, like we did in the previous example, can you find the 120th term? What would you need to find the 120th term? All right. Recursive formula is not, I guess it's not very useful right now. An explicit formula, no problem. You could just plug in that number for n. But in a recursive formula, you need the term right before it. Okay? All right. It's probably going to be a fairly large number. All right. So it has its limitations, the recursive formula. N would be the number, whatever number term that is. T is the number of terms. And I guess we can say that T to the n minus 1, and I think Alex had said that. That is the previous term, whatever that might be. Okay. That is a sequence. Any questions on that? All right. Now we're going to talk about, that was sequence. Let's talk about a series. A series is the sum of a sequence. So the difference between a sequence and a series is a series, I want the sum of those numbers. We're going to add them all together. Okay? And you see this funny looking symbol up there. That is the Greek symbol sigma. and that is a summation symbol. And what this first example says is I want the sum with the bottom number from 1 to 6. This says I want the sum of the first 6 numbers. Okay, and it's easier than what it looks. I want the sum of the first 6 numbers. So what you're going to do is you're going to plug in 1 for k, that's the first term, plus, then you're going to plug in 2 for k, 3 for k, and so on. And you're going to add those numbers together. Right? And you'll find out that the sum here is going to be 63. There's easy ways to do that. Okay. So that's one way you can do this, to find the sum of the first 6 numbers. Actually plug in 1 for k, 2 for k, 3 for k, all the way up to 6. Okay. So we would have 3 plus, no commas, 3 plus 6 plus 9 plus 12, 15, 3 times 6 is 18, and you would add up those numbers to get 63. Three plus 6 is 9, 9 plus 9 is 18, 18 plus 12 is 30, 30 plus 15 is 45, plus 18 is 63. Here's something you can do, because I want to show you a property of this summation. I can take the 3, the coefficient, bring it out front. Because we have that property. There's no name for it. From 1 to 6, I can take the coefficient and bring it out front. Is this easier? Well, let's see how this works. You have that 3 times, and k we're going to put in 1, and then 2, and then 3, 4, 5, and 6. Smaller numbers to add up. 1 plus 2 is 3. 3 plus 3 is 6, plus 4 is 10, plus 5 is 15, and 6 is 21. Bless you. And 3 times 21 is 63. So we do have that property where I can take the coefficient and bring it out front. Okay. The next one. This one starts at 0. It's no big deal. It just means I want, you're going to plug in 0 for k, and then plug in 1 for k, 2 for k, 3, and 4, and add up whatever you get. So it would be 5 times 0 minus 2, 5 times 1 minus 2. Let me erase this here. 5 times 2 minus 2, and so on, and add up the results. Okay, that's how that summation symbol works. For the third example here, we have k squared. From 1 to 5. 1 squared plus 2 squared plus 3 squared, and so on, and add up the results. Okay. I want the sum of the first 5 numbers there. The last example. What do you think that last example means, Andrew? You have any idea? Where it says from k from 1 to 3 of 6. Yes, that's exactly right. So in other words, it's going to be 6, that's your first term, plus 6, plus 6, that's 18. Or 6 times 3, however many you want. That's what Andrew said. If I wanted the sum of the first 10 terms, it'd be 10 times 6, correct? Yes, and that's one of our properties. Did everybody understand what that symbol means now? It's the sum. You want the sum. There are easier ways to find these numbers. Andrew says calculator. Let me show you some formulas. This is the one that Andrew and I were just talking about. C stands for constant. So that if we had that example here, from 1 to 3 of 6, all this means is 3 times 6. So the sum of the first 3 numbers here is 18. That's how a constant might work. The sum of the first 100 numbers of 8 would be 800. Easy enough, right? For a linear series, this is for a constant series. A constant, no variable here, just the numbers 6, the number 8. For a linear series, this is how this works. Let's take a linear series. Let's take the one we just did. Let's take 3K. Okay? And we want from K from 1 to 6. This is how this is going to work. Remember what I said you can do with the 3? Put in front. So let's do that. So let's make that 3 times from 1 to 6 of K. And if you have a linear series, 3K is a linear, right? We know how to recognize a linear equation. The way we work this is 3 times n, in this case, is 6. Look at your formula up here. So it'll be 6 times 6 plus 1 divided by 2. 6 times 7 is 42. 42 divided by 2 is 21. 3 times 21, there's our 63. That's how the formula works for linear. How does it work for quadratic? If you know the formula, it can be easier than a calculator. Trust me on this. Let's see how this works for a quadratic. Let's find the sum of the first 8 numbers in this series. Series means we're adding, of k squared. That means 1 squared plus 2 squared plus 3 squared. We could do that in our calculator. We could do that, come up with an answer, or we could use this formula above that says take n. What is n? What number is n? 8. So we have 8 times 8 plus 1 times 2 times 8 plus 1 divided by 6. And so if we plug that, 72, 8 times 9 is 72. 72 divided by 6 is 12. 12 times 17 is 120 and 84. 204, is that right? And so the sum of the first 8 terms is 204. Okay, how do we do that without a calculator? 12 times 17. You know? Without a calculator? Without paper and pencil? What is it? 12 times 10 plus 12 times 7. So you got 12 times 10, 120. 120 is easy to add a number to, and then 12 times 7 is 84. 120 and 84. Okay. Yeah, that's easy as well. All right. So that's how a constant series, a linear series, and quadratic series works. And we know that we can take the coefficient, like we did in example 2 here, and we can take that 3 out front. Yes, Andrew?
What I was saying with the calculator was not just anything on the line, it's actually a calculator.
I understand that. Yeah, I know that. Yeah, there is summations in your calculator. Okay, so let's take an example here, and let's put all those 3 properties together. And let's find the sum from 1 to 6 of, let's go 5k squared minus 3k plus 20. I want to find the sum of the first 6 terms of that series. Okay, we get the problem? And I'm going to use my 3 formulas there. Now, if you didn't have a chance to write these formulas down, you may want to open your book, and if you didn't have a chance to write them down yet, they're on the bottom of page 694. Okay. First of all, I'm going to split this up into 3 separate sums. So it's going to be 5 times the sum from 1 to 6, that's how that's read, of k squared minus 3 times the sum from 1 to 6 of k plus the sum from 1 to 6 of 20. Five times. Now I'm going to use that formula that says n, which is 6, that's our number of terms, times 7 times 13. Remember 2n plus 1, 2 times 6 is 12, 12 plus 1 is 13 over 6, minus 3 times the sum from 1 to 6 of n times n plus 1 divided by 2. That's our linear formula. Plus, here I can just multiply 6 times 20. All right. The first sum here, the 6's can cancel out. And I have 7 times 13, all right, which is 91. So I have 5 times 91 minus 6 times 7. Well, let's do this. The 2 and the 6, and 3 times 7 is 21. minus 3 times 21, plus 120. And so I have 455, sorry, minus 63, plus 120. Okay, and I think that comes out to be 397, 497, 597, 617, 512. I was close.
Don't
Plus or,
have your money.
plus or minus, whatever. All right, so 512. See, what happens is on Friday, all those numbers get in my head and they start to become jumbled.
Yeah.
I'm sure you know the feeling.
Yeah, click right there.
Okay? So, I'm going to encourage you guys, Dominic,
Yes, sir.
to don't leave this room without doing some of these problems. Okay? We don't want to come in here Monday having not done the homework, or maybe try to do the homework Sunday night or early Monday morning or during first hour. Okay? Because you're not going to remember this stuff. Get as many as you can done now. You've got about a half hour. Your homework is going to be on pages 696 and 697, problems 10 through 40, the evens, and 42 through 72, thirds. That'll be due on Monday. Then I will come around and show you your test scores from yesterday.